Hello everyone. Am I audible? Everybody? Hello guys. Hello everyone. Ellaru happy ah safe ah irka? Hi, hello. So those who are coming, you should like the video, you should subscribe the channel because every day we are running classes for NEET 2026. Hi Puvi, hi. Okay, and also now itself you can share this video with your friends. Okay, so tell me, are you happy? Ready for the session? Ready now? You just give me a thumbs up in the chat box, please. Everybody. So it's me, Lerin Mam. So in we are going to discuss the wonderful chapter that is nothing but kinematics. So first I will tell you how we will be conducting the class, or let's say what is the flow of the class today. So we will be discussing motion in a straight line as well as motion in a plane. Okay, in the rent chapter we will cover as well as we will be covering PYQs as well. Okay, we will cover PYQs as well, and in the PYQs we will cover both NEET level questions, okay, both NEET PYQs as well as JEE PYQs as well, because everybody knows last year the question paper konjam tough irundha. So inniki proper we are starting the backlog series. Appo we should focus in the beginning stage we should focus on some difficulty questions. Yena in the difficulty questions in the competition irukku. Okay, so on the competition we should win. Okay, adukkaga we should work hard. So definitely we should work on the difficult level questions. So in the session in the two chapters, motion in a straight line and plane we will cover NEET as well as JEE questions. Yena that level preparation we need for 2026. And also Pasangala, I want to say one thing. Don't keep your mindset, because I also see many videos in YouTube that saying this question paper is going to be easy as per the patterns, it's going to be moderate easy level. So don't keep your mindset that this year going to be easy paper. Okay, don't keep that mindset. The problem is like if you are thinking like this year it is going to be easy, whether it is easy or difficult, that is not at all a matter. Okay, as I mentioned, in the difficult level questions da unga rank decide pantu poradhu. Okay, last year we are checking on the marks. Let's say I'm just saying 679 and 680. Appadina you can just see the rank difference is coming around 150 to 200. So now you can imagine if there is a change in 4 marks, how much difference will be there in the rank. So each question is important, whether it is easy, moderate, difficult, there is no segregation. We will prepare our mindset to to face a difficult level question paper. Okay, daily physics class the next week we will be having. Okay, don't worry. Next Sunday onwards, we will be having the regular classes, and I will tell you the schedule today. Today I will be giving you the schedule as well. Okay, 12th CBSE we can think another time. Okay, now let's focus on NEET 2026. So we are going for the first chapter. First chapter na motion in a straight line. Okay, so we will be discussing few things. Okay, those who are coming to the session, don't forget to like, share with your friends now itself. Also subscribe the channel for more updates as well as getting high quality classes. Okay, high quality classes you should subscribe now. Okay, Hepsi, good morning. Call your friends also. Let us start. Okay. So motion in a straight line we will go for a quick revision first. Okay, on the quick revision we will be going for the question solving, and first session we will be finished like around 12:30 we will go for a lunch break. Adukapra we will be continue with the motion in a straight line. Okay va? Everybody is okay? Sure Mohammed. Okay, Don't worry. Edachu requirement irunda, as I mentioned, I mean, any of the 12th CBSE class order comment box, you just put a comment. Okay. As I mentioned, I will read the comment, I will give you the reply, also I will give the solution as well. Okay. So don't worry, just put a comment there because right now I will forgo everything, whatever happening here. Okay. Okay. So now, Jayvant. Ma'am, fluids and rotation. Definitely, we will do it. In this backlog series itself, we will do it. Okay. So now, Anta, we are going for the first chapter, motion in a straight line. Okay, va? Ready, ya? Arambikalama? If you guys are ready, give me a fire on the chat box, please. If you guys are ready, give me a fire. Let me get some energy. Okay, so now, as I mentioned, the first thing, Vanta, we have this distance and displacement. I'm not going that base level. Okay, we will just have a quick revision. So in the distance, thank you so much, guys. Okay, so in the distance, we know the total distance traveled. Okay, the total distance traveled by a body, the total path length is known as the distance. Ana vanda displacement. Ana vanda displacement is nothing but the shortest distance. Okay, the shortest distance between initial and final point, or in the shortest distance na enna straight line. Correct? Straight line. Okay, so we can define displacement as the straight line distance or the shortest distance. Okay, and unit vanta same tha rendukume meter. Okay, ana in the distance displacement la vanda rompa important ana point enna distance vanta oru scalar quantity tha. Okay, distance vanda oru scalar quantity tha, displacement vanda vector quantity tha. Okay, and dimension vanda same the L. Okay, now I'm going to give you a very important relation. Okay, very important relation. Good morning. Okay, very important relation. So now you should give me an answer. I'm starting my journey from here. Now I'm walking from A to point B. Okay, in the case I can say that when I'm starting from point A, reached on B, in the time I can say that in the distance displacement oda magnitude one the same. Correct or wrong? It is actually correct. Okay, now what happened? So let us say the 10 meters da. Okay, from A to B it is actually 10 meters. Again I'm starting my journey from A, I'm going to B, and again I'm coming back to the midpoint. Let me just say this is the midpoint that we have and I'm calling it as C. Okay, appa vanda I'm going to B, then to C. Idhila vanda distance na enna? It is nothing but 15 meter. Yena A to B vanda 10 meter and B to C vanda C in the midpoint da. So in the distance vanda 5 meters. Appa total distance vanda 15 meter. Ana displacement order direction anna. Pasangla, tell me. My cute kutties, tell me what is going to be the displacement in this case? What is the displacement in this case? What is the displacement in the case? Get me the answer in the chat box. You people, everybody knows this answer, correct? Tell me. Yes, very good. Akshada Pradeep, right? Akshada, it is it is correct. It is nothing but 5 meters. Okay. And next one, let us say again I'm starting from A. I'm going to B. Again I'm coming back to A. Okay. So how is my journey? A to B, then again B to A. Okay. So ipa vanda in the case distance enna? A to B, then B to C. Distance enna? distance வந்து 20 meters தான். ஏன்னா A to B வந்து 10 and B to A வந்து 10. So total path length வந்து 20 meters. Very good, very good. இப்போ வந்து I just wanted to know the displacement. இந்த கேஸ்ல displacement என்ன? Initial pointum final pointum same தான். Initial and final points வந்து same. அப்படினா displacement வந்து என்ன ஆயிடும்? Final position minus initial position. ரெண்டுமே same தான். So it will be coming as 0. Okay. So now using all this data. Okay. Now using all this data, I already mentioned one thing. Distance வந்து displacement க்கு equal. Okay. That is possible. Now can I write it like this? Yes or no? Distance வந்து greater than displacement. Can I write it like this? Yes or no? Yes or no? Yes or no? Manju? Okay. So tell me, is it possible? Of course, yes. Right, இது வந்து possible தான். And next வந்து I am writing distance less than displacement. இது possible இல்லையா? Distance வந்து displacement விட, it is going to be less than displacement. Is it possible? Can we have any such situation? No. Correct. So இது வந்து possible இல்ல. So அப்போ வந்து I'm just going to make a very very beautiful relation. இது வந்து important தான். இந்த distance will be greater than or equal to the displacement. Okay. So அப்போ வந்து we should take the ratio. Distance divided by displacement ratio வந்து always greater than what? In the relation ரொம்ப important. We can just expect some statement based questions. Okay. So in the distance displacement in the relation வந்து ரொம்ப important. Distance by displacement வந்து always greater than or equal to 1. Displacement cannot be larger than distance at any ways. புரிஞ்சுதா? Understood everybody? Okay. BMNT. Okay, yeah, fine. So now we are going for the whatever we have studied about distance and displacement. In the distance we have mentioned it is a scalar quantity. Adu vanda total, okay, total path length covered by a body. Okay, and also it is a scale, also it can have only positive values. Okay, distance will be always positive values da. Ana displacement la positive possible, 0 is also possible, negative also possible. It can be positive, 0 as well as negative. Understood. So now distance displacement is fine. Now we are going for the another one, that is nothing but the speed and the velocity. So we are going for average speed and average velocity. So average speed and average velocity na enna? Average speed na total distance traveled divided by time. Ana on the average velocity na net displacement divided by time. And in the quantity one the scalar and idu one the vector. Okay, this is not working. Okay, so this is nothing but vector. Okay, so average speed one the scalar and average velocity one the vector quantity. And average speed one the we can have positive values. Okay, I don't know why it is not working. Okay, average speed ku vandu positive values possible. Okay, and the average velocity ku vandu positive, negative, 0 is possible because ipo vandu in the displacement 0 ana average velocity is going to be 0. Appadina always it can be 0, it can be negative, also it can be positive as well. And the same relation whatever we have said in the distance displacement, we can say average speed average speed divided by average velocity will be always greater than or equal to 1. Okay, இப்போ வந்து if you are taking the ratio of this average speed and average velocity, again அது வந்து total distance divided by displacement தான். So it will also have the same relation. We can say average speed வந்து always greater than or equal to average velocity. புரிஞ்சுதா? And in the unit வந்து meter per second, both cases வந்து meter per second, and the dimension வந்து LT raised to -1, same for average velocity as well. Got it? Got it? So, இப்போ வந்து if you have anything which is known as speed, drift velocity or speed of light, whatever it may be, the dimension வந்து same தான். Okay, the unit வந்து same தான். Okay, understood? Now, இப்போ வந்து we are going to discuss this average speed only. ஆனா வந்து we are just going to make little harder. Okay, so அது வந்து let us say we are starting from a point A. இப்போ வந்து we have reached B and now we are moving to C. Okay, we are moving to C. When we are going from A to B, the velocity வந்து V1 and here it is V2. Okay, and one more thing is there, in the distance வந்து x1, in the distance வந்து x2. Okay, இப்போ வந்து I'm going to discuss average speed as well as average velocity. I'm taking this body is moving in a straight line. Okay, so அப்போ வந்து இந்த average velocity speed வந்து same இருக்கும். So இப்போ வந்து you can apply this for both the cases if the direction is not changing. So இப்போ வந்து we know this distance x1 and x2. Okay, now the thing is like this x1 is equal to x2 which is equal to x. Okay, so this is the question. Okay, we have started from point A and reached B and then we are moving from B to C. In the AB cover பண்ணும்போது the velocity that we had is V1. Okay, புரிஞ்சுதா? And the velocity வந்து V1. And B ல இருந்து C ல, I mean when we are going to C, the velocity is V2. Okay, ஆனா வந்து AB and BC வந்து equal தான். Okay, this is the only data given. Okay, even we don't know what is exactly this x value as well. It is given, it is covering equal distance and the first half with V1, second half with the V2. அப்படினா I know that the average speed oda equation வந்து you should stick with this equation only. You don't have to think much. Just stick with the general formula. General formula na enna? Total distance divided by the total time taken. So in the case la vanda total distance na enna? If you are taking this is x1 plus x2, same da, so I can go for 2x. Okay, total time na enna? The time taken for covering AB and the time taken for this BC. So adu vanda T1 plus T2. But ana vanda there is a problem. In the T1, T2 we don't know. Correct? T1, T2 we don't know. So we have to rewrite T1 and T2. Eppadi we will rewrite? How we can just do it? We know velocity or let's say speed vanda distance by time da. Appadina time na enna? Distance divided by speed. In the case la vanda T1 na enna? The time taken for covering AB. Appadina the distance vanda x and on the velocity vanda V1. So tell me what is going to be T2. Tell me what is going to be T2. Give me some tips for what? Okay, we will do it as a separate one. Let us focus on the class, okay? Okay, fine. Okay. So now we are going for T2 vanda x by V2. Ipo vanda we are going to substitute this. So this will be coming as x by V1 plus x by V2. Okay, so idu da vanda our average velocity. Ipo vanda there is again a problem. We don't have x value as well. We know covered equal distance and the value we don't know. The value, the one which we know is what is V1 and V2. And the value mattum da theriyum. Appadina, we are going for, we know this x will be get cancelled. Adukapro we will be having 2 divided by 1 by v1 plus 1 by v2. Correct? 2 divided by 1 by v1 plus 1 by v2. So we can write, we can cross multiply. So we will be getting this one. So we can just rearrange and we will be getting 2v1 v2 divided by v1 plus v2. This is romba important equation. Okay, NEET it is asked multiple times. If you are going back and you are checking the previous year question, you can see using this equation there are multiple questions. Okay, now in the derivation, if you are feeling it's difficult, skip it, study this only. If a body, hey, why this board is like this? If the body is covering, what is this? Okay, if a body is covering with v1 velocity in the first half, v2 velocity in the second half, appadina the average velocity vanda 2v1 v2 divided by v1 plus v2. Okay, I hope you are getting it. 2v1 v2 divided by v1 plus v2. Appadina, let us say, now I am going to ask you, we have 3 equal segments. Okay, I am starting from A to B to C to D. Okay, in the distance AB is equal to BC is equal to CD. Now how we will be finding the average velocity? Let's say we have 4 equal segments. Okay, we have 4 equal segments. Now how we will be finding the average velocity? So adakaga we should go for a general formula. So we can go for n by v average, which is equal to 1 by v1 plus 1 by v2 plus etc plus 1 by vn. If we have 2 equal segments, we can go for 2 by v average, which is equal to 1 by v1 plus 1 by v2. Again, for v average, we will be getting 2 v1 v2 divided by v1 plus v2. Okay, and iduvanta we can apply only if we are covering equal distance. Okay, equal distance, now we can apply this equation, and this is one of the most important question. Okay, how many questions now? We can just expect 1 or 2. Okay, how many questions? Because we can see that relative velocity is there, and kinematics we have motion in a straight line, we have a plane, everything is there, so we can expect 2 questions. Okay, 2 plus questions together kinematics specific we will be saying 1 question. Okay, so understood? In the equation everyone should study this equation. Understood? This equation is very important. Now 4 equal segments, we will go for 4 by v average. Got it? Now again we are starting from A, we reached B, and we are going for C. Done. In the velocity v1, in the velocity v2, the time taken is t1, inga t2. So the known values v1 we know, v2 we know, t1 we know, t2 we know. Now in the case we have to find the average velocity. So let us go for average velocity. What is the general equation? Total distance divided by time. Okay, so in the case of distance directa we don't know. Ana we know velocity is equal to distance by time. Velocity into time distance. Appadina total distance AB plus BC divided by time taken, that is given T1, T2. Okay, இப்போ வந்து we should know what is AB and BC. Can you tell me in the chat box please what is AB and BC? Everybody please. Tell me what is A, B and BC. Yeah, now we know only V1 and V1, V2, T1, T2. We don't know the AB and BC value. Tell me, Dr. Guy, Hepsi. Tell me what is going to be BC, what is going to be AB. So AB one the V1, T1 and this one will be coming as V2, T2 divided by T1 plus T2. இப்போ வந்து let's say T1 is equal to T2 which is equal to T. Okay, the time வந்து equal da. In the case la வந்து time equal. The time what we have taken to cover AB as well as BC வந்து equal. அப்படினா okay அப்படினா how we will change this equation? In the V average வந்து V1T plus V2T divided by T1 plus TT. T1 plus TT வந்து 2T. So TT will be get cancelled and we will be getting V1 plus V2 divided by 2. So when we can use V1 plus V2 divided by 2? Tell me when we can use V1 plus V2 divided by 2 if it is covering the distance with equal time interval. Now, if you know the velocity, you can straightly find the average velocity. Adu vanda V1 plus V2 divided by T. Purinjada, everybody? Everybody understood? Yes or no? If you understood, give me a thumbs up in the chat box, please. Everybody, please. Okay, so now we are going for instantaneous velocity. Instantaneous velocity na and the term illa irukku adu ennanu. Okay, thank you Aditya, thank you Manju and Akshata. Okay, so instantaneous velocity na and the name illa irukku. Instantaneous velocity na enna and the instant la irukra velocity. Ipo vanda let us say we are starting our journey from our house. Okay, so ange irundha we are going to our school. So appa vanda we know that sometimes the road vanda rush ah irukum, sometimes the road vanda free ah irukum, sometimes we will get late, so we will run. So we know that when we cover the distance from our house to the school, what will happen? You will be moving with different velocities. Correct? So ipo vanda once you reach class, so the teacher was asking what was your speed? So appa vanda neenga solradhu da average. Okay, appa vanda you will be saying average. Ana ipo I wanted to know at this second, at this particular point, at this particular second, what was your velocity? Adu vanda instantaneous velocity. The velocity at the instant, at a particular instant is known as instantaneous velocity. And the one we will be finding like this: V is equal to dx by dt. Okay, or we can say the instantaneous velocity was the limit delta t tends to 0, delta x divided by delta t. Delta t tends to 0 da, and the time interval on the small, very small. And the small time interval evlo displacement or evlo distance covered. Adoda ratio tha in the instantaneous velocity. Purinjada? In the instantaneous velocity. So ipo vanda I am giving you the displacement in this format. X is equal to 5t square plus 5. Appadina how you will be finding the instantaneous velocity? We will simply differentiate this. Okay, so ipo vanda we will be getting 10t. Okay, if you know the time, you can just substitute and you can find the answer. Done. Okay, so this is the instantaneous velocity. Now I wanted to give you another one. Okay, the magnitude of instantaneous velocity. Magnitude of instantaneous velocity vanda equal to instantaneous speed. Okay, the magnitude of instantaneous velocity வந்து equal to instantaneous speed. Always. Always இது வந்து true. Okay, so now magnitude of instantaneous velocity will be equal to instantaneous speed. If I am plotting displacement versus time graph, அப்படினா the slope of this graph வந்து the change which is happening in the y-axis, அது வந்து displacement divided by the change which is happening in the x-axis, அது வந்து time. அப்படினா இந்த slope வந்து velocity. Got it, everybody? Understood? Yes or no? Yes or no? Take the notes, because these revision notes will help you to revise during the exam time, because you guys know almost 80-85 days left. So in the 85 days, whatever we are studying, we can't just remember instantly. We should go through the content. Okay, so on the last minute you should go through your short notes. Adukku in the notes helpful ah irukum. Okay, now we can go for another topic. Okay, we are going for the acceleration. Velocity ku appuram we have acceleration. So acceleration na enna? Rate of change of velocity, rate of change of velocity with respect to time. Okay, so அப்படினா we can say the average acceleration வந்து change in velocity divided by delta t. Change in velocity na enna? Vf minus Vi, final minus initial, divided by t. Okay, so இப்போ வந்து we should know this is a vector quantity. Okay, the acceleration வந்து ஒரு vector quantity, அதோட unit வந்து meter per second square, dimension வந்து Lt raised to -2. ஆனா வந்து எனக்கு இப்போ தெரியணும் what is the direction of the acceleration. What is the direction of acceleration? Please let me know in the chat box, guys. From 7th grade onwards, you people are studying acceleration. Now tell me what is going to be the direction of this acceleration. Tell me what is going to be the direction. What is going to be the direction? Tell me guys. Please respond here. Okay, one second. Okay, so what is going to be the direction? Tell me. Those who are coming, you should like also try to respond. Okay, so in the direction one, it will be same as the direction of change in velocity. If we are simply saying velocity and the answer one the wrong. Okay, adu one the wrong answer tha. Okay, the direction of acceleration one the same as the direction of change in velocity. Purinjida? Everybody? Yes or no? Yes or no? Are you guys getting it? Yes or no? Yes or no? So ipo vanta we are going for the instantaneous acceleration. So instantaneous acceleration na enna? Anta particular time la acceleration. Okay, anta particular time la acceleration. Anta acceleration we will be find it as dv by dt. Otherwise we know v na enna? Dx by dt. Appadina we can say d square x by dt square. So in the instantaneous acceleration vanda we can say it is dv by dt. Illena we could say it is nothing but d square x by dt square. Ipo vanta we should study one more important formula for instantaneous acceleration. as we know, it is nothing but dv by dt, right? dv by dt. இப்போ வந்து I'm just going to multiply and divide with dx. Okay, so now I'm making some rearrangement. dv and this dx I'm keeping here, and here we have dx, and in the dt we are putting over here. So இப்போ வந்து dx by dt na enna? dx by dt na enna? Velocity into dv by dx. So acceleration ku vanda right now we got 3 equations. In the 3 equations important da, and what are the equation? Instantaneous acceleration vanda equal to dv by dt. It's also equal to d square x by dt square. It is also equal to v dv by dx. In the 3 equations important for your problem solving. So guys, don't forget to study, because most of the kids won't study the third one, but third one is also very, very important. Ready, yeah? Everybody? Ready? Yes or no? Get me some energy. Okay. So guys, please do like the video. Also call your friends and just, ask them to attend the session. Okay. So Ipavanta, we have seen what is instantaneous acceleration. Okay. Ipavanta, we are going to study few terms which we already know. Okay. First vanta uniform motion. Uniform motion na enna? Uniform motion na enna? Uniform motion na the speed will be constant. Okay, uniform motion na speed will be constant. Now we have uniform acceleration. Okay, uniform acceleration. Uniform acceleration na enna? Acceleration vanda constant. Okay, non-uniform acceleration. Non-uniform acceleration. In the acceleration is not constant. Okay, we should know all these things. Yena next vanta we are going to study nothing but our what equations of motion. Okay, next one the equations of motion da. So adakaga we should understand these 3 terms. So ipo vanda I'm going to start with the equations of motion. In the chapter la vanda the most important, okay, equations of motion. Okay, so in the equations of motion la vanda we should know, let us say, okay, if it is having, or if it is in uniform motion, if any body is in uniform motion, or let's say with uniform velocity, I'll become more specific about it. If it is moving with uniform velocity. Okay, if a body is moving in a uniform velocity. So appadina if it is moving with uniform velocity, anta case la what is the acceleration, guys? Tell me what is going to be the acceleration. Tell me what is going to be the acceleration. Such an easy question. You can give me the answer in the chat box. Tell me. Okay, what is going to be the acceleration? Ipa vanda you should tell me what is the acceleration. Uniform velocity na acceleration vanda 0. Okay, acceleration vanda 0. Okay, next vanda we have uniform acceleration, and that is nothing but a is constant. Okay, so Ibavanta we are going to deal with the very good Akshara, very good. Now we are going to deal with the 3 equations of motion. What are the 3 equations of motion, guys? What are the 3 equations of motion? V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as, right? So these 3 equations, if let's say acceleration is 0, okay, if the acceleration 0 na, what will happen to these equations? Tell me what will happen to these equations. You should tell me what will happen to these equations. first equation வந்து v is equal to u plus 0. So v is equal to u. Second equation வந்து s is equal to ut. Second term வந்து 0. And third la வந்து v square is equal to u square. So, in the madri acceleration 0 na, the only possible equation, which means any body which is exhibiting uniform velocity, okay, uniform velocity, then we can use the only equation velocity is equal to displacement by time. This is the only equation we can use, because in the equations of motion when we are putting acceleration is equal to 0, in the case what will happen? The only equation suitable will be v is equal to s by t. Ana, if acceleration is constant, we can use all three equations. Now, in the acceleration constant, we cannot use this equation. We should go for integration for finding the values. Purinjada? So first one, if the acceleration is 0, okay, if the acceleration of 0 means if it is uniform, it is moving with uniform velocity. Appadina, the only equation possible is v is equal to displacement by time. Ipa one the acceleration constant. Appadina, we can use all three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Okay? Ipa one the acceleration constant allena, which means it is a non-uniform acceleration. Na? In the three equation we cannot use. We cannot use all three equation. We should go for, if it is non-uniform, we will go for integration for finding the values. And also, along with this three equation u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Along with this, you should study one more equation, that is nothing but s(n)th. Okay, displacement in the nth second, and that will be coming as u plus a by 2 into 2n minus 1. So in the four equations, it is very important. If you wanted to mark stars, you can just draw the whole stars. Okay, so we have four equations. So in the second equation, in the fourth equation, what is the difference? Okay, so let us say, for example, let us say I'm dropping something. Okay, I'm dropping something. So when I'm dropping t is equal to 0. Okay, after 5 seconds, it will travel some distance. Okay, it will travel some distance. And the distance we will be going for the second equation. The total distance traveled in t time. Okay, so this one the total distance. Okay, total distance traveled or the total displacement in t time. Ana idu vanda, let us, I am becoming more specific. Okay, when we are dropping t is equal to 0, and after 1 second, 2 second, 3 second, it will just cover few distance, or let's say displacement, because whatever I am saying, it is same. The displacement and distance in this case is same. So whenever I am dropping something, in each and every second it will cover some distance. So in a particular second, second, what is the displacement? Okay, that is what nth, I mean the displacement in nth second. Okay, second equation வந்து இந்த 5 secondsல எவ்வளோ travel பண்ணிருக்கு, and in the fourth caseல வந்து in the 5th secondல or in the 4th secondல 3rd secondல எவ்வளோ distance, அந்த 1 secondல எவ்வளோ distance travel பண்ணிருக்கு. Okay, or on the 1 secondல what is the displacement, அதுதான் s(n)th. புரிஞ்சுதா everybody? புரிஞ்சுதா? Yes or no? Everybody please let me know in the chat box. Yes or no? Yes or no? Yes, thank you Hasini. So இப்போ வந்து we are going to discuss. Okay, thank you Manju, thank you Akshada, very good. So இப்போ வந்து we are going for if it is a non-uniform accelerated motion. Appadina, we can use few equation. If it is variable acceleration, acceleration oda equation vanda dv by dt. Ipo vanda we have to find v. Okay, if we have to find v, appadina we will write dv which is equal to adt. Purinjada? Ipo vanda we know acceleration is equal to dv by dt and we can write dv which is equal to adt. Appadina I wanted to know the total change in velocity. Adikaga I will do integration in the both the sides. So I will be getting delta v in the left hand side and here I have to integrate. Okay everybody? Understood everybody? So this is the important relation. Now let us say we have v which is equal to dx by dt. So v dt will be coming as dx. So if you wanted to find the change in, or let's say if you wanted to find the displacement, you can go for integration here. Okay. Next one, we have one more equation for acceleration, v dv by dx. In the case of I'm taking this dx over here. So a dx will be equal to v dv. So we can just integrate and we can find the corresponding values. Understood or not everybody? Yes or no? Yes or no? So we are going for the major application of this thing, that is nothing but motion under gravity. Okay, and after that we will be going for the different types of graphs. Adukapra we will be going for the the problem solving. Okay, then lunch break ta. Adukapra we will start motion in a plane. Okay, okay va? Ready ya? Okay, registration things we can discuss later da. Just focus on the class. Okay, adukapra we can discuss. Okay, so very simple tha idu, very simple. In the acceleration one, the variable acceleration. Okay, constant na, we don't have any confusion. We will use the equations of motion. Okay, now one the acceleration variable. Acceleration variable na, we have to find, let us say we know dv by dt the acceleration. Okay, so now one the acceleration, you have the acceleration and you should find the change in velocity. Okay, you should find the change in velocity. Appadina, we should go for a dt which is equal to dv. Okay, so in the small, the small change in velocity one the dv. Appadina, the total one the how we will be finding it. In the madri we have small dv's. Okay, we will sum up all these dv's. Adakaga what we will be doing, the process we are doing to find the sum of all small segments is nothing but integration. So I will integrate both the sides. So if one I will be getting delta v as integral a dt. Okay. Adukapro let us say we know acceleration one the dv by dx. Okay. If one in the acceleration is given in terms of distance. Appadina we know a dx which is equal to v dv. Now we can integrate both the sides and we will be getting another value which we need. Got it? Understood? Yes or no? Yes or no? Okay. So now we are going for the important one, motion under gravity. Okay, motion under gravity. So this actually we are doing it is the application of these equations of motion. Okay, so whatever we have studied we are going to apply here. Okay, so motion under gravity we have to deal few cases. So in the first case we are just standing on the top of a building. Okay, we are standing on the top of a building and we are throwing, or let's say we are dropping a stone. Okay, we are dropping a stone. So in the case if let's say dropping a stone, releasing a stone, then you can straightly take u is equal to 0. In the initial velocity vanda 0. Okay, when we release, when we drop, we can just straightly say the initial velocity vanda 0. Okay, and in the case, we should check some of the directions. Okay, so in the case motion under gravity, which means the only acceleration, whatever I am throwing, the ball, stone, whatever it may be, in the stone experience pandra, or let's say the force experienced by the stone is nothing but the gravity, or let's say gravitational force. Okay, appadina there is only one acceleration, and that is nothing but g, and the other direction vanda downwards. Okay, g, it is coming downwards. Purinjida? Understood everybody? Okay, so dropping a stone, we can take the initial velocity vanda 0 and g direction vanda negative. Okay, so ipa vanda we are calculating it from here. So idu vanda h. Okay, so ipa vanda we have u, we have the displacement. Basically what is going to be the displacement? Adu vanda nothing but the height of the building. Okay, so appadina I just wanted to know, if I'm dropping something, what is going to be the time taken by the stone to reach the ground? Okay, first we are going to find the time taken by the stone to reach the ground. So adakaga the time I'm taking it as capital T. Okay, so in the capital T we are going to find, and we know u, which is equal to 0, and g, or let's say acceleration, is nothing but g meter per second square, which is acting downwards, and the displacement in the case of displacement one the h, that is also in the downward direction. Okay, so whenever we are solving this type of question, listen here, this is very, very important, because most of the students will get confused. Which direction we have to take, positive, negative, all these confusions. Okay, you can take any direction as positive. Okay, if you wanted to take whatever be the quantities which is acting upwards as positive, take it, no worries. Okay, or if you want whatever be the quantities which is acting downwards as positive, fine. So in the case of vanda, I am going to take that whatever acting downwards, positive. Okay, so the direction I am choosing downward as positive. Okay, so this thing you have to keep for the entire problem. Okay, in between you can't change. Okay, so whatever is acting in the downward direction, adu vanda positive. Okay, so ipa vanda you have u, a and s, and you need to find t. Which equation of motion we can use? First one, v is equal to u plus at. Second one, s is equal to ut plus half at square, and v square, which is equal to u square plus 2as. So to find time 1, 2, 3, which one we can use? We can go for s is equal to ut plus half at square. And in the case of yes vanda the displacement. In the case of the displacement in the downward direction, magnitude vanda h, and downward we are taking as positive. So upper vanda we can say this is h. And u vanda 0, so ut vanda 0. And plus half into a na acceleration in the case of very good Akshada, very good. Okay, which one is coming as acceleration? Adu vanda acceleration due to gravity. Acceleration due to gravity, the direction is downward. Ana what we have fixed, the direction in the whatever is acting downwards vanda positive. Appadina we can go for plus g into the time we are taking t square. Appadina I can just write h is equal to half g t square. Ipo vanda I am taking all this here, 2h by g, which is equal to t square. Appadina the time taken by the stone to reach the ground vanda root of 2h by g. Important ana relation, and if possible you can just study by heart, because yes we can, no worries. Let us I will do after this. Okay, no worries, so then you won't be having any confusion. Okay, so let's just wait. So ipa vanta we have studied t is equal to root of 2h by g. So if it is possible, if you can do this in 10 seconds, okay, hardly 10 seconds, now you don't need to by heart. Okay, otherwise if you think I will think about the signs and everything, I'll take time, then by heart it, because for the exam hardly we will be getting 1 minute for one question, so we don't have much time to waste. Okay, so if I want the same thing, I'm going to change the direction. So we know the displacement, I will write the displacement one the h downward direction, acceleration one the g downward direction, u one the 0. Okay, and we need to find t, and we have already decided this is the equation we will be using here. So if I want the displacement downward, what I'm taking? Downward direction as negative. Previously we have taken it as positive. Okay, so if I want the, you can check S is nothing but the displacement in the downward direction na negative, so minus h. Okay, which is equal to ut0 plus half into a, again g value, which is also in the downward direction. Downward direction now we will again keep minus g t square. Now if you are writing this minus h minus half g t square, negative will be get cancelled. Again we will be getting t is equal to root 2h by g. Okay, so the only thing is like you can take any direction. Nobody is going to question you which direction you have, why you have taken this. The only thing is like as per our convenience, we can take the direction as positive or negative. But till completing the problem, you should maintain the same direction, same sign. That is the only deal. Otherwise, there is no confusion, nothing. So, why I have done in the previous case, why I have taken downward as positive, which means, because always when we have more negative quantities, this will make some kind of problems. So, to make it more positive, that is why I have taken. It is not necessary that you have to take it. If you have planned this thing, you can go for it. Okay? At least now if you can start, okay, now if you can start, you can. It is not something which is not possible, because I mean, you guys know that all the students will be more aggressive in the last 3-4 months. Okay, so you can try, nobody is going to stop you, but again you are still asking, you are still confused. So keep your mind that, I mean, just set your mind that, yeah, I can do it, I will do it, I will get the admission. Okay, and it is not easy to get 700 plus marks. So adakaga you have to work really hard. Okay, it is not something like I will do 100 questions per day. That is also not enough. Okay, it is also not enough. If you can do 500-600 questions per day, that will take you to 𝐏𝐻 Delhi. Okay, so that is the only thing. Don't think it is going to be easy. It is going to be moderate. Okay, the journey is going to be difficult. Okay, to get till 550, 600 in the last 3 months is easy. Okay, it is easy. If you are ready to work, it is easy. Anna, to get 700 plus in the 3 months, if you are very much aggressive, if you are very much determined, do it now. Okay, don't even ask. Just go ahead. You can. Okay. So now we have studied the time taken. I hope, Manju, your confusion has been sorted. So now we are going for another one. What is that? What is that? Tell me. We are going to find the velocity just before reaching the ground. Okay, the velocity just before reaching the ground. Purinjida? So ipavanta we have, okay, ipavanta we have velocity just before reaching the ground. Again the same scenario, we are dropping something, okay, we are dropping something from a particular height, that is nothing but capital H, and the only acceleration what we have is g. So since it is dropping, again we will be starting with u is equal to 0, a is equal to g meter per second square, and displacement is h, that is also in the downward direction. Ipavanda we have to find the find the final velocity. So we have we have u, we have a, we have s, and we need to find the final velocity. Which equation we can go for it, guys? Can you just give me the answer in the chat box, please? Which equation? V square is equal to u square plus 2a. Yes. So again, v square I'll keep it as it is. U square 1 the 0. Okay. In this case also I'm taking downward as positive. So appadina 2 into g downwards positive. So I'll be taking g into s, that is h. It is also downward. So I'll be getting 2gh. So v will be coming as root 2gh. Okay. So now we can, very good Manju. Okay. Very good Aditya. So now the thing is like the velocity just before reaching the ground one, the v is equal to root of 2gh. Understood everybody? Any confusion so far? Please let me know in the chat box, please, because motion under gravity is very important. Done? Done? Now we are going to deal another one, which means I'm standing on the ground. I'm throwing something with a velocity u. Okay? I'm standing in the ground and I'm throwing something upwards. What will happen? It will go up to a height. Again, it will come back with the same velocity. So, what I want to know first, I wanted to know the maximum height. Okay? So, the maximum height that this stone can attain. That is what I wanted to find first. Okay. So again, what are the things what we have? We have acceleration due to gravity acting downwards, and we have the initial velocity, and we need to find the h. Okay. And at the topmost point, okay, at the topmost point, what is the velocity, guys? At the topmost point, what is the velocity? Tell me. What is the velocity at the topmost point? What is the velocity? What is the velocity? A change in the reversing the direction. So for that instant, the velocity will be very good, Akshada. Okay, velocity, yes, Hasini. Velocity will be 0. Yes, Advait, Aditya, very good, Manju. So now we can have u is there, that value we know. Final velocity at the topmost point, the velocity is 0. And we should find the maximum height attained, okay? Acceleration which is acting downwards and u is acting upwards, okay? So now you have to tell me which equation we can use to find h. Which equation we can use? Tell me in the chat box, please. Which equation we can use? We can go for v square, which is equal to u square plus 2as. So v square is nothing but 0, and I'm taking positive direction. Okay, upward as positive. So appadina we will be getting u square, and here we have a is acceleration, right? So a is acceleration, and that the direction is downward. So I'll be taking minus 2gh. So we will be getting u square is equal to 2gh, u square by 2g, which is equal to h. So this is again another important relation in this case. When we throw something with an initial velocity, the maximum height attained by the particle will be coming as u square by g. And I have taken positive upward and negative downwards. In the case of u is acting upwards, so u positive, and g is acting downwards, so g negative. Okay, so we will be getting h is equal to u square by 2g. Now I'm going to find the time taken, the total time taken by this body. So total time na enna? Time which is taken to reach the maximum height, and the time taken to reach the ground from the maximum height. So can I write the time is nothing but t1 plus t2? And what is the advantage? This two time, which means the time of ascending and descent, will be coming as same. You can just see that We are starting with the velocity u, it will reach us to 0. Again 0 to u, okay, same distance. So on the time vanda, it is going to be equal. So appadina t is equal to t1 plus t2. Okay, what we need to find? The time taken. So ipo vanda I'm going to find this time to reach the maximum height. Okay, once I got it, I can multiply with 2. Okay, understood everybody? So now I am going to find this t. T means time of ascent. Okay, so again I know what is u, I know what is v. Okay, on the topmost point lavanta 0, and I know the acceleration due to gravity as well. So which equation we can use? We can go for v is equal to u plus at, 0 is equal to u minus gt. So u will be equal to gt and t will be equal to u by g, and total time of flight will be 2t. So 2u by g is going to be the total time taken by the body. Okay, very easy thing. We are standing on the ground. Okay, if we are throwing something, it will come down. Okay, so it will go up to a height and it is coming back. Okay, so if I'm throwing with a velocity u, and on the topmost point the velocity will get reversed. Upon what will happen? The velocity vanta 0. So now it will again go down. Okay, so I just wanted to know the time taken for the whole process. So what will happen? The time taken here is time of ascent and time of descent. So the total time the time taken to reach the maximum height plus the time taken to reach the ground, and these two values want the same. Okay, now we can directly use another one. Okay, we can just directly use another equation. Let me go for s is equal to ut plus half at square. Okay, so in the case yes, I'm explaining Advait. Okay, so in the case you just understand. Okay, what is the displacement? Can you tell me in this case, which means we are throwing with an initial velocity, again it will come back. In the case what is going to be the displacement happened? Can you tell me the answer in the chat box? Can you tell me the answer in the chat box? Let me just check who is going to give the answer first. Tell me the answer. What is the displacement? The initial point is here, final point is also here. So what is going to be that? Idu vanda 0. Correct? Idu vanda 0. Initial velocity irukku. Now I'm going to find the total time. So I'm just using capital T. Okay. Now plus half into what is the acceleration? Acceleration is minus g t square. Now we can write ut which is equal to half g t square. This will be get cancelled. Again we will be getting 2u by g. Any equation we can use and we will be getting. Very good Akshada and Manju. Okay, very good. Okay, so any equation you can use and you can find it. Okay, so this time of flight vanda 2u by g. Okay, you can do in any of the method, no worries, whatever you are choosing, it's not a big deal. Okay, so in the previous case what we are doing, we are throwing, it will go up to maximum height, it will come. The total time the time taken to reach maximum height and to come back. So t1 plus t2. Okay, and in the t1 and t2 the same. Appadina total time of flight 2 into t. T na the time taken to reach half of the distance, or let's say to reach the half of the motion. Got it? Okay, so appadina we can just go for using v is equal to u plus at and we can substitute and we can find it. Everybody understood? Any confusion so far? Please let me know, please. Everybody. Everybody, please let me know. So already we have, Gopika, we have already done the basic mathematics and vector lecture in the last I think 2 days back. So if you are not feeling much confident, you can watch the lecture, because as I mentioned, it is not the time to ask. Okay, if you are feeling like you are weak, just go and do whatever you want to do, which means the solution we have to find, right? Basic mathematics difficult, na? You should study basic mathematics. Otherwise, we don't have any other choice. Okay, so if you are weak in basic mathematics, na, physics one romba difficult item, because almost 60-70% of questions in the basic mathematics we have to apply. Okay, so appadina you should be very good in it. Okay, I'm your Malayali student, really. Okay, so those who are coming, don't forget to like and also share with your friends. Okay, so now we can go for the graphs. Okay, after that we can just go for the questions. Okay, so graph la we have studied the displacement time graph. Displacement time graph la vanda what was the slope of displacement time graph? What was the slope of displacement time graph? It is nothing but velocity. Okay, so if this graph is like this is displacement, this is time. So tell me what you understood from this. D is marked in y axis and T is in the x axis. Now guys, you have to tell me what is your understanding about this diagram. What about velocity? We know the slope is velocity, correct? In the graph velocity da idu. And the velocity ke vonjam specialities irukku. In the madri graph vandena, you should strike that. What is that? Idu vanda constant. Okay, so in the case la vanda velocity vanda constant. Understood? Understood? Yes or no? Okay. Very good, very good. Okay, so now we have again displacement time graph, and the graph is like this. Now you should tell me, is it an increasing graph or a decreasing graph? Is it an increasing graph or decreasing graph? How we will be finding it? We know the slope vanda tan theta. Okay, so tan theta, what is slope? We will draw a tangent, right? So we have draw a tangent over here. And what is the angle made with the x-axis? So this is the angle theta 1 and this is the angle theta 2. So just tell me at point A and B, which one is having more slope? Which one is having more slope? Tell me which one is having more slope? Which one is having more slope? A or B? A or B? It is nothing but 4B. The slope of B is more than that of A. So which means this is increasing graph. Okay, the velocity is increasing. Understood or not? Understood or not? Now we are going for another graph like this. So now you should tell me this is representing increasing graph. Okay, now you should tell me this. Is it a decreasing or increasing graph? What we will do? We will go for the tangent. So if I'm taking a point over here. So this is what the tangent over here. And here I will be doing another one. So you can just see that this is making theta 1 and this is making theta 2. So in the case of let us say this is A and this is B. So in the case of which one is having more slope? Which one is having more slope? Slope of A is more than slope of B, which means velocity of A is greater than velocity of B, which means this is representing a decreasing velocity. Very good guys, very good. I hope you guys are getting it. Yes or no? Yes or no? Okay, so now we are going for the velocity time graph. Okay, so in the velocity time graph we are going to plot velocity time and the slope is like this. So what it is representing? What it is representing? Tell me. These are all very, very important. I will just make it little shorter ones. Okay, So this is what the graph VT, and we are getting the slope here. So tell me, what is this representing? What is this representing? Slope is nothing but delta V by T, which means nothing but acceleration. The slope of velocity time graph one the acceleration, and in this case the acceleration is constant. Now we have another graph over here. So tell me what is happening here? What is happening here? What is happening here? Here in this case the velocity is constant. Velocity is always constant. It is not changing. Appadina the slope, or let's say acceleration. What is going to be the acceleration? What is going to be the acceleration? What is going to be the acceleration? In the slope one the tan theta. Here it is going to be 0. So acceleration one the 0. Purinjada everybody? Everybody understood? Everybody understood? Yes or no? So ipavanta we have another graph over here. Okay. So let me just say this is how the graph is. Okay. So this is representing increasing or decreasing graph. Increasing or decreasing graph. Or let's say positive. Acceleration is positive or negative. So idhula vanda acceleration vanda positive, and idhula vanda acceleration vanda negative. Yena this is making an angle theta, and here it is an obtuse angle. So here angle vanda acute, which means less than 90 degree. Less than 90 degree na tan theta vanda positive. Tan theta positive na acceleration vanda positive. And here what will happen? In the theta vanda obtuse angle na more than 90 degree. Appadina what will happen? Tan theta becomes negative, because when we studied the basic mathematics chapter in the second quarter la vanda in the tan theta vanda negative tha. Okay, understood everybody? Yes or no? Please let me know in the chat box, please. Please let me know in the chat box. Okay, so now we should go for another one, area under the velocity time graph. So ipavanta, let's say here we have velocity, here we have time. So ipavanta I wanted to find this area. So what is this area? What is this area? Tell me. Area under VT graph. So in the case la vanta, how you will be finding the area? How you will be finding the area? Tell me how you will be finding the area. Yes, it is constant and positive. Yeah. So what is the area? Here. It is nothing but velocity into time, right? How you will be finding the area? Velocity into time. Velocity into time na enna? Displacement. So appadina I can say that area under the VT graph vanda displacement. So whatever be the area, velocity time. So we will be finding integral V dt to find the area, because we know integration is nothing but used for finding the area. So appadina we will be getting the displacement. Okay, next one we should go for the area under the acceleration time graph. So let us say again, you just go with the basic diagram. This is acceleration, this is time. So Ipavanta, you should tell me what is going to be this area. Tell me what is going to be this area. It is nothing but change in velocity. Again, don't say velocity, it is change in velocity. Acceleration one to always connected the change in velocity. Don't simply say velocity. That is wrong. You won't be getting the score. Okay. So change in velocity tha. So we can just say A is equal to dV by dt. Appadina integral A dt vanda we will be getting delta V. Okay. So to find the area, we will go for the integration. Understood? Any confusion, anything so far? Okay, so we are done the quick revision of motion in a straight line. Now we are quickly going for the question part. Okay, so guys, you have to be with me. We should work on this. So let us start. A vehicle travels half the distance with the speed v, the remaining with the speed 2v. Its average speed is, you will find it very simply. I'm damn sure about it. You will just give me the answer because we already done this. If it is covering equal distance, here it is mentioned half the distance. Appadina we have an equation. Tell me what is going to be that. Give me the option quickly. I want it now. Let me refresh because I want quick answers. Where is your answers, guys? Yes, yes, yes. What is the equation? What is the equation we can use? 2v1 v2 divided by v1 plus v2, and v1 one the v, v2 one the 2v. Now to find the average speed, we are going to substitute these values, v1 one the v, and this is 2v divided by v plus 2v. Appadina we will be getting 4v square divided by 3v. So we will be getting 4 by 3v. Hence option B. Very good, Akshata, very good. Okay. Now let us go for the next question. Okay. A toy car with charge Q moves on a frictionless horizontal plane. Okay, frictionless horizontal plane. Very good, Manju, very good. Okay. So now the surface under the influence of uniform velocity. Pavanta, we have a charge. Forget about the car and all. We have a charge. Okay, it is under or it is influenced by an electric field. So of course, Vanta in the charge or force experience agum. And the force order value we know, we have studied in electrostatics. Appadina, the force experienced will be coming as QE. Okay. Now due to the force QE, its velocity increases from 0 to 6 meter per second in 1 second. Okay, at that instant, I mean after 1 second, the direction of the electric field is reversed. Okay, ippadi irundha direction vanda ipo ennachu, first of all it was the direction, now it becomes in the opposite direction, reversed. The car continues to move for 2 more seconds. Okay, 2 more seconds. The average velocity and the average speed of the toy car between 0 to 3 seconds. Okay, so ipavanta we have to find the average velocity and average speed. So basically vanta we will be going for the average velocity equation. Average velocity na enna? Displacement, the net displacement divided by time, and average speed vanda total distance traveled divided by time. So this is the basic equation. Now you should just make this question into small parts. Okay, first the thing is like we have a charge, electric field is in this direction, now it is experiencing a force that is QE. Okay, and what happened in 1 second, it has reached a velocity 6 meter per second from 0. Now we can find the acceleration. Correct? Okay. So let us find the acceleration first. Acceleration na change in velocity divided by time. So inge final velocity vanta 6 meter per second minus 0 initial divided by time vanda 1. So acceleration vanda 6 meter per second square. Understood everybody? So acceleration vanda 6 meter per second square. Okay, done everybody? Yes or no? Okay, acceleration vanda 6 meter per second. Now I wanted to know in the 1 second la evlo distance in the charge, I mean how much distance it has travelled. Appadina we can go for, we know what is u, we know acceleration, we know time. Appadina tell me which equation we can go for to find the distance travelled in the first 1 second. Distance travelled in the distance travelled in 1 second, in the first 1 second. We can go for S is equal to ut plus half at square. So, now S will be coming as u 0 plus half into a 6 and this 1 square. Appadina S will be coming as 3 meters. So, in the 1 second, this has been travelled for 3 meters. Okay, correct? So, we understood in 1 second, the displacement the 3 meter. Okay, so initially it was here, now it has reached here, and the distance the 3 meter. In the point la the velocity 0, and here it is 6 meter per second. And after that, in the question it is mentioned, it was travelled to 2 more seconds. Okay, it has travelled 2 more seconds. Appadina, okay, appadina, you just focus. What will happen here? What will happen here? We can just make it into 1 second. Okay, so after 1 second, what is going to be the velocity? Okay, what is going to be after 1 second? Let me just say it is reaching over here. Okay, what is going to be the velocity? How we will be finding it? How we will be finding it? If I'm just considering BC, okay, I'm just considering BC because I wanted to know initially B il irukumbodhu adoda velocity 6 meter per second da. Appadina when it has traveled for 1 more second, okay, and the direction changes, the electric field changes, appadina adu retardation. Okay, appadina adu retardation. Then we can go for u is equal to 6 meter per second. Okay, and the time 1 second. Acceleration minus 6 meter per second square. Why we have taken minus 6 meter per second square? Because direction reverse aachu, adinala force oda direction opposite agum, adinala acceleration minus 6. Understood? Understood na? Just give me a thumbs up in the chat box. Okay, so first we have made the first part. The first part in the 1 second la ivlo distance travel pannirken. Okay, adoda adu attain panna velocity 6 meter per second. In the next 1 second la what is going to happen? Adudha what we are going to discuss. Adukku we understood time 1 second da, and on the B point la irukra velocity 6 meter per second da, acceleration minus 6 meter per second square. Appadina, I'm going to use V is equal to U plus AT to find the velocity at the point C. So, VC will be coming as U 6, okay, minus acceleration minus 6 into time 1. So, VC 0 meter per second. So, after 1 second in the charge ki enna agum? It was started from 0, it will come to, it attained the maximum velocity 6 meter per second. Ana ipa the direction reverse pannadanaala, idoda velocity decrease aachu, and the velocity ipo 0. Okay, so at this point, the velocity 0 meter per second. Okay, it is coming as 0, which means there is a direction reversal happening over there. Okay, 6 meter per second la irundha 6 0 ஆச்சு. இன்னும் next 1 second la it is not going to move forward. ஏன்னா you just understand initially the field இப்படி இந்த direction la da. So I will also, the charge will also move in the same direction. And now in the charge 6 meter per second velocity ஆச்சு. அந்த point la direction reverse ஆச்சு. So it will again move and it will come to rest. Then it will move in the backward direction. So, இப்போ we have understood in the point the first 2 seconds we understood. Now in the last 1 second the question 0 to 3 meter per second, 0 to 1 second, 1 second to 2 second, and in the 2 second to 3 second. What is going to happen? Okay, so now listen. BC the velocity 6 to 0 ஆச்சு. Acceleration minus 6. So can we find the length, the distance travelled in that segment BC? Which equation we can use, guys? Can you just give me the equation in the chat box? First one, second one, third one, which one? Which one we will use? S is equal to ut plus half at square. So, S will be equal to, in the case of ut na 6 into 1. Okay? Minus, yena, idu vanta retardation. So, half into 6 into 1 square. So, appadina 6 minus 3, again, S2 vanda, in the distance vanda, enna aidu, that will be coming as 3 meters. Okay? Okay, so first segment la, very good Aditya. Okay, first segment la, yes, Manju, everybody, very good. Okay, in the first segment la vanda velocity 0 and velocity attained 6 meter per second. Distance traveled 3 meter. Okay, second segment la vanda velocity 6, acceleration retardation da, and final velocity 0 and the distance traveled is 3. Okay, wow. And again now we understood velocity 0 achu. Ipo the direction reverse panna pore. Now we should focus on CB. Okay, and what is the initial velocity? Velocity at C, we know it is 0. We should find when it is coming back, what is going to be the final velocity. Adakaga we know time, we know acceleration. Appadina u plus at and v vanda 0 minus 6 into 1. Okay, so idu vanda represent in the negative sign represent pandrathu the velocity vanda in the opposite direction la. Appadina we will be getting when it reaches at this point, again it will attain a velocity 6 meter per second. Ipa vanda I should find the length. S is equal to ut plus half at square. Idhula vanda ut na enna 0 because the initial velocity vanda 0 da. So half into that I will put minus for acceleration 6 into 1 square. So idu vanda minus 3 meter. Purinjida in the question purinjida everybody. Okay, it's little hard, it is little long, but ana vanta romba easy ana question. Okay, so ipa vanta na total distance traveled will be S1 plus S2, S3 will be coming as 15 meters in 3 seconds, and the displacement vanda 3 meters in 3 seconds. So ipo we can apply in the final equation and you can go for the answer. Can you just give me the answer in the chat box, please? If you understood, give me the answer in the chat box. Give me the answer in the chat box, please. Everybody give me the answer. So, in the question la average velocity, average speed we need to find. Time both cases la 3 seconds that is given in the question. So, in the question la we should find the displacement and the distance traveled. Then only we can find average velocity and speed. Okay, those who have not understood, listen now. Okay, so average velocity kyo, average speed we should find the displacement as well as distance. Okay, so in the displacement or let's say distance when we calculate, we should know the whole scenario. In the 0 velocity lerunda, it has reached to 6 meter per second. So on the time the acceleration we can find. Once we got the acceleration, in the 1 second la evlo distance travel pannirukke, we will be get to know. Okay, and in the next segment na 6 meter per second velocity la irukke ipo, and the direction reverse pannadanaala it will experience retardation and the velocity comes to 0. Okay, ipo vanta velocity 0. Okay, velocity vanta 0. Velocity 0 na it is changing its direction. Adanala we can just go for the initial velocity 0, and when it is coming back, what is going to be the velocity, we will find it. Once we get the all velocities, we can find the distances in each segment. So distance now we won't consider the negative sign, we will only go for the positive signs. And displacement now we know we will only focus on the initial and final points. So appadina we will be get it is nothing but 3 meter. So average velocity, average speed. Average velocity na total displacement one the 3 divided by 3. So it will be 1 meter per second. And inge what will happen? It is 9 divided by t one the 3. So it is 3 meter per second. Understood everybody? Yes or no? Please let me know in the chat box, guys, please. Okay, so now we are going to take a break. After that, we will again continue with the questions in the straight line. Adukapra we will be starting motion in a plane. Okay, okay. So now the time 12:30. So can we meet at 1:10 again? Yes or no? When we can meet again, guys? 1:10 will work. So guys, we will meet at 1:10. So have your lunch, take a proper break, drink a plenty of water, and in the next session, we are again going to continue the PYQs. Then we will be starting motion in a plane. So everybody be ready on, you should come on time, and we are going to do more more hard level questions. Okay? So see you guys. Just enjoy your lunch and come back. See you. Hi, hello. Are you guys there? Hello, everybody. Hi, 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 hi. Hi, Shakti, Abhinay. Yes, others, where are you guys? If you're here, give me a heart, please. Everybody. Everybody, if you guys are here, please give me a heart. Then we can together start the session. Good, 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 good. Yes. So let us just start the session. Are you guys ready? ஆரம்பிக்கலாமா? ரெடியா? Tell me. So we are going to continue with the questions, whatever be the questions we were doing. So this is a very simple question. Quicker, you can just give me the answer, okay? A car runs at constant speed on a circular track of radius 100 meters, taking 62.8 seconds for every circular lap. Okay? So the radius was 100 meter tha. So in the 100 meter cover பண்றதுக்கு they are taking a time 62.8 seconds. Okay? Average velocity and average speed and okay? Quicker, you can give me the answer. Average velocity, average speed. So first one we can just ignore these two options. Yeah, average velocity vanta 0 ஆக போற. Why? Why it is 0? ஏன்னா the displacement வந்து 0. Okay, அதுக்கப்புறம் we should check what is the distance. Correct. And in the case வந்து the B option வந்து 0 தான், that is possible இல்ல. And second case வந்து 10 meter per second. So அதுதான் right answer. Okay, so without doing calculation you can find the answer in this case. And how we will be finding average speed? The distance, total distance divided by time. So the total distance na enna in the question la? Very good guys, very good, superb. Okay, so the total distance vandu enna in the question la? Distance vandu 2 pi r, right, divided by the time. So while we are substituting, we will get the answer. As I mentioned, it is not even necessary to do the calculation. Yena the options vanda romba easy ah irukku. So whenever you are getting questions like this in NEET, you can just check this possibility. Okay. So next one, we have a particle with unit mass undergoes one-dimensional motion such that the velocity varies like this: v of x, which is equal to beta x to the power minus 2n. Beta and n are constants. X is the position of the particle. The acceleration of the particle, can we find it? In the equation which use in the question we can solve. Which equation? Acceleration, which is equal to dv by dt. Is it possible? No. Yena idu vandu it is given in terms of position. Adinala we should use this equation v dv by dx. So first one you have to find dv by dx, then you have to substitute. Can you give me the answer in the chat box? Koncham quicker, faster you can try. Okay, I have given all the equations, everything. Just do the calculation. Increase your speed, guys. Increase your speed. Also, don't forget to like. Like is important for me. Also, subscribe the channel because every day we are conducting class for you people. So everyone should subscribe the channel. Okay, va? Okay, va? So, இப்போ வந்து dv by dx. dv by dx na inga beta x to the power 2n. So beta vandu constant. So ipo vandu we have to differentiate d by dx of x to the power minus 2n. So d by dx of x raised to n vandu we know minus 2nx raised to, or let's say nx raised to n minus 1. So we will be getting like this. Okay, so dv by dx we got it. Now in the step we have to substitute v, then whatever we got it, so beta is there, so I'm just putting it as beta square, then we have a minus 2, then we have 2n, then x raised to minus 2n minus 1. So இதுதான் வந்து the result. So minus b square 2n minus b square 2n, and now we have to equate with the powers. Powers na enna? X to the power minus 2n irukku, x to the power minus 2n minus 1 kuda irukku. Now we can just do like this, minus 2n beta square x to the power minus 4n minus 1. So idhula vanda which is the answer? Which is the right answer? Very good, Hasini. Very good. Yes, Abhinay, Manju. Very good. Super. Akshada. So Vanta, we will be getting the answer as option D. Now Vanta, we have a particle again moves in the x direction in time t, and the relation Vanta, it is given as x is equal to t plus 5 all to the power minus 1. In the case of Vanta, we have to find acceleration is proportional to in terms of velocity or in terms of distance. Can you find it, guys? Can you find it for me? So very simple. We know in the case of x Vanta t in terms of t. So first we can just go for velocity. Yena acceleration find பண்றதுக்கு முன்னாடி we should find v. V na enna dx by dt. அதுக்கப்புறம் we should go for acceleration dv by dt. அதுக்கப்புறம் we should try in different ways, like how it is connecting with velocity, how it is connecting with this one. Okay. So actually, Shreyas, the thing is like we will be I think tomorrow also you have class. So high weightage chapters I will do it separately, individual sessions, and that is running right now. And in the next Sunday and Monday we will be finishing all the concept revision. Okay, all chapters we will cover in the upcoming Sunday and Monday. Adukapro we will be going for PYQ series. Okay, PYQ series for 2 days, and 2 days we will be doing numericals plus expected questions. Okay, wow, Shreyas. Okay. So in the question eppadi pandrathu, we will be going for d by dt of t plus 5 all to the power minus 1. So this will be giving you minus 1 t plus 5 minus 2, because this you will be using the chain rule. Okay, and into this d by dt of t plus 5 on the 1, so we don't have to write it. So we got minus t plus 5 all to the power minus 2. Now we have to do d by dt of minus is already there, t plus 5 all to the power minus 2. So again we will be using chain rule. Chain rule eppadi use pandrathu? We will be taking u is equal to t plus 5. Okay, so appadina we are actually doing dy by what we are finding? We are finding velocity, right? So we can just go for, we will be finding dx divided by du into du by dt. So that is what we are actually doing. So now we can just go for dx. Okay, so in the case la vanta x vanta u raised to minus 1. Okay, x vanta u raised to minus 1. Appadina d by du vanta u raised to minus 1. So minus 1 u raised to minus 2. We will substitute what is u. Okay, adukapro we will be going for du by dt. U na d by dt of u na t plus 5. Adu vanta 1. Okay, so we have just substituted here. And now we are going for here. So already or minus sign irukku. Now what will happen? Minus 2 t plus 5 raised to minus 3. Okay, minus 3. So idu vanthu we will be having already a minus sign and we will be multiplied with n x raised to n minus 1, n vanthu minus 2, x vanthu t plus 5 and minus 2 minus 1 vanthu minus 3. Okay, so idu da nama final answer. So we can just write 2 into t plus 5 all to the power minus 3. Ipo vanthu we should try how to write in terms of velocity and distance. So distance vanthu t plus 5 all raised to minus 1 da. Correct? T plus 5 all raised to minus 1. So appadina we can just go for distance whole cube will be coming as acceleration. Adu option la illa. Okay. Now we are going for velocity. Velocity vanthu t plus 5 all to the power 2. Okay. So appadina we should get the acceleration in terms of velocity. So just get me the answer in the chat box now. Everybody, please try. Everybody. So what is going to be the answer? We will be getting the answer as v to the power 3 by 2. Option I think 1, right? Yeah, option 1 is going to be the answer. Next one, the acceleration of a particle is increasing linearly with the time t as bt. So and the acceleration one which is equal to bt. The particle starts from origin. So when t is equal to 0, x vanthu 0. Okay, and initial velocity is also coming as v0. The distance travelled by the particle. எப்படி நம்ம கண்டுபிடிக்க போறேன்? Because we understood in the acceleration வந்து uniform இல்ல. Because as acceleration வந்து it is depending upon time. So அதனால we cannot go for the equations of motion. புரிஞ்சுதா first step? இது வந்து non-uniform accelerated motion. அதனால we cannot use equations of motion. அந்த டைம்ல which one will help us to do it? We know integral a dt will give integral dv or let's say change in velocity. அப்படினா இங்க வந்து a na bt dt it will be coming as bt square by 2. Okay, and that is equal to the final velocity minus initial velocity tha. நமக்கு வேண்டியது final velocity. So we can just go for bt square by 2 plus v0 which is equal to v. Okay, ஏனா the initial condition is given, the initial velocity வந்து v0. Now we got v. The question is to find the distance traveled. அதுக்காக we can go for integral v dt. So integral v na bt square by 2 plus v0 dt. So now we will give this integration individually. So bt square by dt plus integral v0 t. So appadina we will be getting b by 2 into t cube by 3 plus v0 t illa, it is dt. Okay, so we will be getting t. Okay, now we know the initial condition there. So the displacement we don't need to give as a constant, it will be coming as 0. So what we got? bt cube by 6. Okay, bt cube by 6 plus v0 t. So the option C da. Purinjida, everybody understood? Yes or no? Yes or no? Tell me, guys, you got it? So next one, the body travels 102.5 meters in the nth second and 115 in n plus 2th second. Okay, this is in nth second. The acceleration, we need to find the acceleration in this question. Very good, Shreyas, very good, very good. We need to find the acceleration. Can we find it, guys? Can we go for it? So whatever we are going to do, these are all JE level questions. Okay, so ipa we have a body and nth second la 102. Okay, appadina nth second la distance, how we will be finding it? It will be coming as u plus a by 2 n minus 2 n minus 1. Appadina in the case la u, even if we are, we can keep u. Okay, at the end you will get to know, plus a by 2. In the first case, n da, so we don't need to rewrite. Second case, 115, which is equal to initial velocity same da. So we plus a by 2 into 2 into n plus 2 minus 1. So we will be getting u plus a by 2. Now 2n plus 4 minus 1. So now we will be getting u plus a by 2, 2n plus 3 as 150. Now what we can do, now we got two equations. This is equation 1 and this is equation 2. Okay, now I'm going for equation 2 minus 1. Okay, do that. 115 minus 1 not 2.5. Okay, and in the right hand side la u plus a by 2 2n plus 3 minus u minus a by 2 2n minus 1, and find what is acceleration. 2 will be get cancelled and we need to get the acceleration. Left side la 12.5 correct. Right side la we should find acceleration. Okay, so this is what will happen in the I have told you 12th we can do separately. This is the NEET class. I will do all the chapters in Sunday and Monday. You don't have to worry about it. Okay, so right now the sessions are going on, so you can just watch the videos and I will be uploading in every day. Also, I'm just going to do some quick revision sessions, like every chapter under 10 minutes for CBSE 12th. So better you can just, if you have studied in the last minute, you can just go for the video, and I have done the mind map also, so you can just work on it. Fine. Okay, so now u will be get cancelled, and what else we have? This 2 will be get cancelled, and we will be having 3a by 2 plus a by 2. So we will be getting 4a by 2. So we will be getting 2a, which is equal to 12.5. Understood? Understood? Yes or no? Okay. So very simple question. We will be subtract both the equation. So we will be getting 115 minus 102.5 12.5. Okay, now we should keep the rest of the terms in the right hand side. Right hand side we know that here we have u plus a by 2 2n plus 3. Okay, now here we will be having minus u minus a by 2 2n minus 1. Okay, so this is how it is. So u will go. Right now what else we have? A by 2 is there. Then we have 2n plus 3. Then we have minus 2n plus 1. Because minus will be coming as plus. Now what we will be getting? Minus will be get cancelled. And this one the 4a by 2. Understood? Got it? Okay. Yes, we will do. Don't worry. Now the distance travelled by an object t is given by, this is a very simple question, s is equal to 2.5 t square. We need to find the instantaneous speed at t is equal to 5. ds by dt, so that's 5t, so t 5, so we will be getting 25. Okay, so the 25 meter per second in the instantaneous velocity. Now we have another question. Two trains A and B, length L and 4L. Okay, one is having length L, another one is having 4L. traveling into a tunnel of length L. Okay, so these are all going to a tunnel which is having a length capital L. Okay. Now, in parallel tracks from opposite direction. So, idu vanda ippadi vandena, in the 4L vanda opposite direction. And the velocity, okay, in the A order velocity vanda 108 and B order velocity vanda 72. Okay, and kilometer per hour given, so we have to go for 5/18. Okay, we have to go for 5/18. If train A takes 35 seconds less time than B to cross the tunnel, then length L will be. Okay, and in the L vanta 60 times the length of the train A. So, you have to tell me what is the velocity of A in meter per second. What is the velocity of A in meter per second? Tell me, what is the velocity of A in meter per second? Because it is given in kilometer per hour, right? And the answer is in meter. So, we have to convert anyway. So, tell me, what is going to be the velocity? Quicker, you can give me the answer. 108 kilometer per hour into 5/18. Very good, very good. Appo vandu VB. VB na enna? VB na enna? This one will be 30 meter per second and this one will be coming as 20 meter per second. Till this everybody understood? Till this everybody understood? Very good, Shreyas, very good. Okay. So, ipo we have train B and train A. Idoda length vanta L, idoda length vanta 4L. Okay. And now we should find the time taken. Okay. We should find the time taken. Yena, the time taken by A. Okay, in the A vanda, inge da tunnel start பண்றது, inge da tunnel, முடியிறது. அப்படினா, in the train, இதுக்குள்ள வந்துடும். So, let us say, the length of the train is L and the length of the tunnel is capital L. So, the total distance to cross this will be the total distance traveled by train A will be L plus L. Okay, then only it will. So, right now this is the train. This is the train. So, to cross this, this has to travel this distance and now it should reach us here. So, the total distance will be coming as L plus L. Okay, and we know the velocity of A vanda 30. Appadina, the time taken by A will be L plus L divided by 30. Am I right or wrong? Am I right or wrong? Ipa vanta we are going to find the total distance traveled by B. Tell me, what is the total distance traveled by B? What is the total distance traveled by B? The length vanta 4L and it has to travel L distance inside the tunnel. Appadina, the total length vanda, what is going to be the total length? What is going to be the total length? It will be coming as 4L plus capital L. And we know the velocity vanda 20. So, now TB will be coming as 4L plus capital L divided by 20. Now, again coming back to the question. If train A takes 35 seconds less than B, appadina I can make a relation here. TA minus TB will be coming as 35 seconds. Can I write it like this? Yes or no? Very good, Krish. Okay. Aditya, very good. Okay. For NEET or today's session, today it will be motion in a plane, of course, kinematics, right? Okay. So, ipa vanta we got TA minus TB vanta 35 seconds, okay? TA minus TB, which is equal to 35 seconds. Why we said this? It is clearly mentioned if train A takes 35 seconds less than B. Okay, so the equation we have to just rearrange. TB is taking more time. So, TB minus TA, which is equal to 35 seconds. Now, we can substitute the values. TB na enna? 4L 4L plus capital L divided by, what was the velocity? What was the velocity of B? 20. So 20 minus L plus L divided by 30, which is equal to 35. Now you can do the calculation. Everybody understood the question? So we have train A to cover, or let's say to cross the tunnel, it will be taking L plus L distance. Second train vandu adoda length vandu 4L and it has to travel the length of the thing. Okay, got it? Ipo we have understood train B is taking 35 seconds more. Appadina we know when we subtract we will be getting 35 seconds. TB minus TA vanta, it will be coming as 35 seconds. Appadina now we can just go for it. So this how we can do it? Let us multiply this with 3. Okay, and we can do it with 2. So appadina we will be getting 12L plus 3L, and here we have minus 2L plus, not plus, minus 2L divided by 60, which is equal to 35. Am I right or wrong? Here we will be multiply with 3. So we will be getting 4L plus 3L divided by 60. And inga vanta we will be getting 2L plus 2L divided by 60, and a minus we will plane. So in motion in a plane, we are going with nothing but the the projectile motion. So in projectile motion, give me a second. Okay, so in projectile motion, we are projecting something with an initial velocity. So first one, we are going to discuss ground to ground projectile. So when we are projecting something with an initial velocity, it will be follows a parabolic path, and the only force acting on the body, whatever we are projecting, is nothing but the gravitational force, or let's say it is the only acceleration that the thing which we are throwing is, it will be coming as what? The our projectile will be coming as the acceleration due to gravity. So now we can say we are projecting with U, and at every instant what is exactly happening? The velocity will change. And how we will be finding the velocity? We will draw a tangent. Okay, we will draw a tangent. Every point we will be getting the velocity by drawing the tangent. Okay, and once it reaches the topmost point, what will happen? The direction of velocity will reverse. So every point we will be getting the tangent. Okay. Now focus over here. We have this U, and we know the acceleration due to gravity is acting downwards. So we can say this will be going in till the topmost point. Since the acceleration in the downward direction, the velocity will reduce. Understood? The velocity will reduce. Got it everybody? So in the first half, which means till it reaches the maximum height, the velocity will reduce. Once after that, what is happening? The velocity will increase in the opposite, or let's say in the downward direction. Purinjida? So first one, we are projecting the stone or ball, that is what we are calling it as the projectile. Okay, and we are throwing this projectile, it is going up and then it will come to the ground again. In this case, what will happen? It will go like this, and once it reaches the topmost point, due to the acceleration due to gravity, the velocity will reduce. and from the topmost point it will again increase. Got it? Everybody understood? So now we will be going for the sum of the important facts in the projectile motion. So now you can see that there is an initial velocity u, and it is making an angle theta with the projectile. So this will be coming as u cos theta, which means the x component, and the y component will be coming as u sin theta. Okay, we will be having u cos theta and we will be having u sin theta as the two components of initial velocity. So then we can say u will be equal to uxi plus uyj. Then ux will be coming as u cos theta I cap plus u sin theta j cap. Understood? Okay, so we will be getting the two components of initial velocity. Now I'm just going to ask you at this point, okay, at this point, let me just write, this is A. This is after a time t seconds, okay, after t seconds, the projectile has reached at the point A. Appadina, what will happen to the velocity? I just wanted to know the velocity at point A. Okay, we need to know the velocity at point A. So we know the time, we know the initial velocity in the y-axis, in the x-axis, right? So ipo we have to find it. Okay, so now the thing is like, the fact is there is acceleration, okay, that is only in the vertical axis. Okay, that is only in the vertical axis. Only the acceleration is only in the vertical axis. And in the x-axis, in the x direction, or let's say in the horizontal direction, what will happen? In the horizontal direction, what will happen, guys? In the horizontal direction, there will be, okay, in the horizontal direction, there will be a there won't be any sort of acceleration, which means in the horizontal direction it will be exhibiting a very or let's say it will be exhibiting uniform motion. Okay, it will be exhibiting uniform motion. Uniform motion, now the velocity will be, it will moves with the, since there is no acceleration in the x-axis, we can say the velocity will be constant. Okay, so if I'm checking on the velocity at this point, which is u cos theta, then if I'm finding the velocity in the x direction at point, that will also come as u cos theta. Understood? At the point A, the velocity in the x direction will be coming as u cos theta. Now we should find what is going to be the y component. So we will be going for the y component of A. So for that we will be using the equations of motion. So uy plus ayt. So uy now u sin theta, and acceleration is in the downward direction, velocity is in the upward direction. So I'll be taking minus gt. Understood? Understood, everyone? Got it? So now we got vy in the at the point A. Okay, already the x component we already know it, that is u cos theta. Ipo we have to find vy. Okay, so we will be getting u sin theta minus gt. Okay, u sin theta minus gt. So we can say the velocity at the point A will be coming as u cos theta, which is in the x direction, plus u sin theta minus gt j cap. So this is going to be the velocity at the point A. So like this way, if you know the basic facts about projectile motion, we can do all the problems, everything coming from this chapter. As I mentioned, it is projected with the initial velocity u, and it is making an angle theta with the horizontal. Okay. So we have a projectile over here. We have a projectile over here, and here we have u, and this angle is nothing but theta. So now we will be make it into components ux and uy. So right now there are components, or let's say there is acceleration, and we can say ay, which is coming as g, which is acting downwards. Ax is nothing but 0. Uy is u sine theta, and ux is nothing but u cos theta. Okay, so this is what the thing. Now we understood when it reaches the topmost point, what will happen? The velocity, due to the acceleration, the velocity in the y direction reduces, and now from the topmost, once it reaches the topmost point, idu the direction switch pandrum, or let's say it will reverse the direction. Appadina the topmost point ila vy 0 and vx u cos theta, because there is no acceleration in the x-axis, or let's say in the horizontal direction. Understood everybody? So ipo we have vy as well as vx. Okay, topmost point la varumbodhu, topmost point la irundha in the direction in the y-axis ila it will reverse. So vy will become 0 and vx will be there. So if I'm asking you the velocity at the topmost point will be coming as u cos theta. Yena and the point la vy will be coming as 0. Everybody understood? Everybody? So now we can go for finding few things. As I mentioned, at any random point, if the time is given, now we know how to find the velocity. Right now we are going to find few things like maximum height, the time of flight, as well as the horizontal range. First one, we are going for the time of flight. Okay, we are going for the time of flight. So in the time of flight la what is time of flight? The total time taken by the projectile to cover the whole distance. Again it wants to come to the ground. Adukkaga evlo time. Okay, what is the total time it will take? That is what t. So appadina we have t over here, sorry, u over here. This is theta. Idu u cos theta. And this is nothing but u sine theta. So now you have two components, and we can say that if you are considering the whole motion, okay, you are considering the whole motion, the displacement in the y direction la vanda 0. Okay, displacement initial ingada, final ingada. So there is no displacement if you are considering the whole motion. Sy vanda 0. Okay, uy we know that is nothing but u sine theta. Ay we know that is minus g. Okay, and the time taken for it, we are taking it as capital T. Now we can say that S is equal to ut plus half at square. I'm going to substitute, or I'm going to do it only for the y-axis. Then Sy will be coming as 0, uy will be u sine theta t, and here we will be getting half gt square. So u sine theta t, which is equal to half gt square. Now you will be getting t, and t square will be get cancelled. So 2u sine theta divided by g will be coming as the total time of flight. Everybody understood? The total time of flight was the 2u sine theta by g. Got it everybody? Yes or no? Yes or no? So now we got this one, 2u sine theta by g, which is equal to t. Ipavanta, I just wanted to know half of the time taken to reach the maximum height. That will be coming as u sine theta divided by g, which means the total time of flight divided by 2. Next one, we are going for finding the maximum height. The total, the displacement happened in the y-axis. So I'm just considering half of the motion. I'm considering half of the motion. So ipavanta, we can just see that initial velocity u, we know x and y components, and topmost point la vanda we have only the velocity in the x direction. Vy vanda 0. Vy 0. Ay is minus g meter per second square. Then uy vanda u sin theta. So then to find this distance, we can use the third equation of motion. Again, we are using it for the y-axis. Okay. So now vy square vanda 0, u vanda u square sin square theta minus 2g into the maximum height. Appadina we will be getting 2gh, which is equal to u square sin square theta, h which is equal to u square sin square theta divided by 2g. So this is what the maximum height. Okay. So next one we are going to find the range. Range na enna? The total displacement happened in the x-axis. Okay, the total displacement happened in the x-axis, and we will call it as our horizontal range. And we know in the x direction la velocity vanta u cos theta, and there is no acceleration, ax vanta 0. Okay, appadina we can just say we know that if it is a uniform motion, the only equation which we can use is s is equal to ut. S vanta r and u vanta ux, t vanta the total time. So appadina we will be getting r is equal to ux into t, we can write it as 2u sin theta divided by g. Ux na u cos theta, so 2u sin theta by g, and we know 2 sin theta cos theta is nothing but sin 2 theta. So then we can say range is equal to u square sin 2 theta by g. So all these equations are very important. H is equal to u square sin square theta by 2g. R is equal to u square sin 2 theta by g. And time of flight, which is equal to 2u sin theta by g. And also if you are studying this equation, already we have done motion under gravity. In that, if you are just keeping theta is equal to 90 degree, what is theta? Angle of projection. What is angle of projection? The angle between horizontal and the initial velocity vector. Appadina in the one dimension la vanda, when we throw something, the angle made with the ground which is coming as 90 degree. So if you are substituting, the maximum height attained will be u square by 2g in one dimension. Okay, and here range vanda 0, because in the one dimension there won't be any displacement happening here. And also time vanda 2u by g, and we know the half to reach the maximum height vanta u by g. So if you are studying these equation, you can utilize there also. And in the range vanta, we should study few more things. Range equation, as we said, u square sin 2 theta divided by g. Ipo vanta we need the maximum range. Okay, maximum range. And the maximum range kaga theta vanda 45 degree. Okay, theta vanda 45 degree. Appadina we can say u square by g is going to be the maximum range value. Understood? The maximum range value is nothing but theta when theta is 45 degree. Then only sin 2 theta will become the maximum. So sin 2 theta we should get the maximum value, which is 1. Okay, so when it will happen? When this side is become 90. So 2 theta will become 90 and theta will become 45. Understood everybody? Yes or no? Yes or no? So now we got R max. And another thing which is related with the range is nothing but we are projecting with two different angles, but the range is same. So to make this range same, the only thing is like these angles should be complementary angles. Complementary angles na enna? theta 1 plus theta 2 should be 90 degree. When we are adding these two angles, if we are getting 90 degree, which means this will be having the same range. Understood everybody? Understood? Yes or no? Yes or no? Now we have done with the ground projectile, ground to ground projectile. Another important projection one, the horizontal projection. Okay, horizontal projection. Horizontal projection. So in the horizontal projection la vanda, we can see that when we are standing on the top of a building and we are projecting something with an initial velocity u, appadina it will be follows a path like this. Okay, so there is only initially there is only one velocity in the x direction. Okay, now we can say that ux is equal to u, uy which is equal to 0, ax which is equal to 0, ay which is equal to minus g meter per second square. Okay, and even in this case you can also take the direction g as positive. Okay, it is downwards because all the rest of the quantities are acting in the downward direction. Okay, so already we are projecting something from a height h. So the displacement in the y-axis one the h. So in the case what is going to be the time taken by the projectile to reach the ground? Okay, so appadina we can just say that in the case sy one the h, ay one the g, uy one the 0. We need time. For that we can go for s is equal to ut plus half at square. Again I'm substituting for only y axis. So adanala this will be coming as h is equal to 0 plus half into g t square. So we will be getting again 2h by g root as the time of flight. Understood? So in the horizontal projection lo kuda we are getting the time of flight as root of 2h by g. It is depending upon the height. Okay, next one we should know when we have projected it with a velocity u. Okay, it will reach us the ground like this. Okay, it will reach us the ground like this. Appadina what is going to be just before reaching the ground, what is going to be the velocity? Okay, what is going to be the velocity? To find that velocity we can just go for, we should know vx as well as vy. So we know there is no acceleration in the x-axis. So this will be coming as u. Whatever be the projected velocity, since it is horizontal projection, vx will be coming as u. And vy will be coming as, we can go for uy plus ayt. Okay, so now one the uy na 0 plus, as I mentioned, I'm taking downward as positive since all the quantities are acting downwards, and t. Okay, so vy will be coming as gt. Appadina this velocity just before reaching the ground will be coming as vx I cap plus vy j cap, and vx I cap one the u I cap plus gt j cap. Okay, so ippa you can find the magnitude as root of u square plus g square t square. And now if you are just substituting for t value in a root of 2h by g. If you are substituting this, you will be getting the magnitude as root of u square plus 2gh also. So the velocity just before reaching the ground one the root of u square plus 2gh. Purinchida? Everybody understood? Yes or no? Yes or no? Okay. So ippa we have done the horizontal projection as well. In the horizontal projection what is going to be the range? Range again, what is the velocity in the x direction into the time of flight. So in the case the x velocity, the velocity in the x direction the u and time the t. So we can say root of 2h by g as the range. Understood? Everyone understood? Yes or no? Yes or no? So next one, we are going for, hello? Okay, so now we are going for the another case that is nothing but oblique projection. Okay, we are going for the oblique projection. For that, from a particular height, we will be throwing with a velocity u. Okay, we are throwing with a velocity u. Okay, so now we can say that, there will be a velocity component here, that is u cos theta, and another component here that is coming as u sin theta if this angle is theta. Again, what will happen? It will go like this. Understood? It will go like this. Then what will happen? Again we have, the same way we have done for the rest of the cases, we will do here as well. So again, we need to know the velocity when it reaches the ground, and this height also we know, which is h. Okay, again g is the only acceleration that we have, and in this case again upward positive we will take because few quantities are acting upwards. Okay, so in the question like if we are just going for oblique projection, there will be quadratic equation will be there in the it will be having a quadratic equation, and to solve that, and we will be getting the time of flight and everything. Okay, and now if I'm just going for the time of flight, as you know, sy, which is equal to uyt plus half ayt square. So idhula vantu sy na h, I will go for minus h since it is measuring from the top to bottom. Next one, uy vantu u sin theta, and t we will be keep it as t because that is what we need to find, minus half into gt square. As I said, right now you got a quadratic equation and you should solve this to find t. Understood everyone? So this is how we will be finding the time of flight. Okay, now coming to the velocity, just before reaching the ground, what is the velocity? Okay, so again this velocity also have the x component as well as the y component, so that y component will be negative because it is acting downwards. Okay, so now Vx will be coming as u cos theta only because there is no acceleration in the x direction. Now we are going for the Vy component. Okay, Vy component. For that we should know Vy na uy plus ayt. Now uy is nothing but u sin theta and ay is minus gt. Okay, so we can substitute that u sin theta minus gt j cap is coming as the Vy. And if you need to find, the magnitude of this velocity just before reaching the ground, you will be getting u square cos square theta minus u square sin square theta, okay, minus what we will be having, we need to, okay, so we will be getting u sin theta minus gt the whole square. Okay, and after doing this again you will be getting u square plus 2gh, or let's say u square plus gt whole square will be coming as the final velocity, and these are all very, very important relations.